Okay. So we're starting this recording off with our correction to the 3.3 problem. The first one that we worked through here, where we had more to do with the number of nickels and the number of quarters, and the original answer that we had did not work out to be as we wanted it to. So the error was made on my part. You guys ended up finding the correction to that and the error that I made. So we're going to go through and take a look at how we correct that accordingly, and then we'll move on to 3.4 directly after that. So jumping over to our whiteboard. So this was our original setup that we had. Now, the actual setup within the buckets that we have here is correct. Where the error showed up is how I interpreted writing these things out as a general equation. And the error came up primarily in this last part here. So while I was telling you that we need to multiply directly down or vertically with each of these, it is correct until we need to get to our result. So the error that came up is that I wrote in this additional multiplying by 2q plus 12 at the very end. The way we have this equation set up right now, this tells us the value based on the number of nickels that we have, plus the value based on the number of quarters that we have, should equal just our total value, not our total value times the total number of coins that we have, because that's actually going to throw the entire thing off. So my error showed up, and this is where problem showed up in that other recording, is I multiplied these two things together, when really I did not need that at all. So really, the correct equation that we should have is this one here. Oops, equals. Don't need to make more mistakes on this thing. It's $2.10. So this is what our original equation should be looking like. And again, that was an error on my end. It's my bad on that front. So we do not want this one. Oops. We do not want this one. We do want this one here. So we'll go through just fairly quickly, but show you guys again our process for getting to that final answer, those final answers. Oops, 210 there. Combine those together. So we're combining like terms on the left-hand side. I want to get the q, the variable terms all by themselves, and yeah, this is going to work out much better here. Those cancel. And it should be 1.5. Divide both sides by 0.3. 0.3 cancels on the left-hand side. Do I have that right? Oops, no, it's typed that part in wrong. Go divided by. There we go. And there's the answer that we should be getting. So the number of quarters that we have is 5. Now, how do we find the number of nickels? Again, we were told that the number of nickels is 12 more than quarters. So we could write that down below or off to the side or somewhere else on our paper. Nickels is number of quarters plus 12, because we have 12 more than that. So we're going to have 5 plus 12 is 17. So the number of nickels that we have is 17. So that's the correction from the early part on that. So there's the error that I made on that originally. But now we have our correct answers of 5/4 and 17 nickels. So again, make sure when you're writing these things out, again, I think the labeling helps out a fair amount with this, is determining, okay, what am I setting up my equation to solve for? So this one was set up to tell me the value, so my result should only be that value there. So that was an error on my part. Don't make my mistake. I'm going through this. I think I rushed my process a little bit there, so slowing down a bit will definitely help on going through and solving that thing moving forward. Okay. So it's making up the last of the stuff that I made a mistake on from 3.3, but we're going to move on into 3.4, working with some geometry problems. So I'm going to jump us over to our notes for that. Okay, so we have 3.4 right down here. So 3.4 has us working with triangles, rectangles, and the Pythagorean theorem. So a fair amount of stuff should be reviewed to us, but again, I'll go through it fairly quickly here. So we're working with triangles. Just some properties of triangles. The sum of the three interior angles of a triangle always adds up to equal 180 degrees. So the measure of angle A, measure of angle B, plus measure of angle C, they all add up to 180. So this angle plus this angle plus this angle always adds up to 180. With any triangle that you have been given, it's always going to be the case. We have the equation for the perimeter of a triangle, which is adding all of the three sides together. You can label these A, B, C, however you would want to, but just adding the three sides together. The area, or rectangle, or our triangle, is 1/2 base times the height. Height can also be written as the altitude. It depends on the problem that we've been given, but base and height is the more common one. And then we have our definition of a right triangle, which has us having one of the interior angles, one of these three angles we have here, is 90 degrees. And we'll always see that, or more often than not, see that denoted with having this little square showing up in here. So this example triangle that we have, 90-degree triangle, or 90-degree angle, so we have a right triangle. And then we also have the Pythagorean theorem, which also works with triangles. And it only works with right triangles, meaning triangles that contain one angle that is 90 degrees measurement. When we are working with the Pythagorean theorem, the parts that represent A and B, which are the legs of the triangle, these can be interchanged. You could swap this one to be A, you could swap this one to be B. It does not matter. It's your choice on which one is labeled as what. And that also translates into the equation itself. These A and B values, these two could be interchanged however you want them to be. It's your choice. That being said, C, which represents the hypotenuse, must always be the hypotenuse, these problems. There is no way and no reason that you should be switching this to be anything else in the triangle. So the legs of this thing, they can be interchanged. The hypotenuse cannot. No way, no reason you should be doing that. It will only give you wrong answers if you do that. So you're going through these. Okay. Now, working with the Pythagorean theorem, it's primarily used to tell us the lengths of a missing, or the length of a missing leg of a triangle, which means if I know two of these three legs, I could solve for the third one, whatever that missing one is, based on what I have been given and what I can plug into my Pythagorean theorem. So we'll go through an example of this, but I want to give you guys a quick process that I would recommend with these, because I think the visual is really nice, especially with geometry. So first off, draw a picture of the scenario, including that triangle and what you are observing, and then label that picture along each of the sides as you need to. Determine which values or which sides are A, B, and C, and then plug those values into the equation that we have for the Pythagorean theorem. So we draw out a triangle, we label it with the values accordingly, and we determine where it gets plugged into our Pythagorean theorem, and we solve for that remaining variable. We can check our final answer by plugging everything back into the Pythagorean theorem, into the respective variables, and then simplifying both sides. If both sides are equal to one another, then we have a correct solution. We will find more often than not that when we are working through these using the Pythagorean theorem, that we are probably going to have decimals showing up with this. Unless the problem specifies otherwise, it's generally not a bad idea to round to 2 or 3 decimal places. That being said, if and or when I ask you guys to use the Pythagorean theorem on the tests, I will be specifying to you guys in the directions, round your answer to the nearest 2 decimal places, 3 decimal places, the nearest 100th, the nearest 1,000th, something like that. I do not want you guys to have to guess at how many decimal places to round to. I don't think that's a very reasonable expectation for me to put on you guys as students. So look for the problem to see, look in the problem's directions to see if it tells you round your answer accordingly. And if it doesn't, again, default to 2 or 3 decimal places as a good place to start with. I will try and take that out on the test for you guys so you don't have to worry about it. We then have some other information regarding rectangles. So rectangles, by their definition, consists of 4 right angles. We have the equation for their perimeter, which is 2 times the length plus 2 times the width, or adding all 4 sides together. And then we have the equation for the area of a rectangle, which is the area is equal to base times height, or written as the length times the width. It's kind of interchangeable in how you want to write those out for yourselves. So we have some information regarding rectangles. We have information regarding triangles written out for us here. Now I will also note to you guys, I do have a file uploaded on our Canvas site. This is again under the useful files section. I can't remember if I labeled it as geometry info or geometry properties. It's a PDF file, but this is what that file looks like. And it just has a big long list of geometric formulas. So information about rectangles, about squares, some stuff about triangles, as they've got a couple rows for themselves here. But it has a lot of these equations and a lot of these things that we can and will be working with in here. Some of them are a bit unnecessary for this class. Like I don't think we're going to be working with cones too much. I don't think we work with spheres more than a couple times. But some very useful geometric information that if you're not going to be using it in this class, you may very well be using it in the next class. But again, this is found under the useful files section of our Canvas site, and it should be labeled as either geometry properties, or it might be labeled as geometry info on there. I don't know if I changed the name on it yet. But you are more than welcome again to view, download, print out, edit, take notes on. Use this as you're going through the homework, and however else you may or may not need that moving forward. But I would highly recommend getting this because I think it's a fantastic cheat sheet on a bunch of these geometric formulas for yourselves. So go check that out if you need it, you want it. It's meant to be there for you guys to use. So we're going to go through a couple examples of working with these formulas, this information, and some story problems that could go along with it. So we're going to reference these 3, and again, we're going to follow our general process of setting up and making a visual for ourselves. I think geometry problems lend themselves very, very well to having and working with pictures and visualizations of these. So our first problem that we have, Roger decides to take the scenic route from home to reach his new fancy restaurant directly next to Stan's, and travels 6 miles north and then 12 miles west. How far away is Roger's restaurant from home if he were to travel in a straight line? Round it to the nearest 100th. Okay. So this is a problem that we're working with. I'm going to jump us over to our Blackboard, and we're going to set this thing up with a visual, and we'll solve it from there. So as we have been told in the problem, again, I'll reread this thing off. Roger decides to take the scenic route from home to reach his new fancy restaurant directly next to Stan's, and travels 6 miles north and then 12 miles west. How far away is Roger's restaurant from home if he were to travel in a straight line? So let's make a visual of this thing. So it's assuming he starts right here. So here's where home is. I'll label that for ourselves. Now we are told in the problem he travels 6 miles north. So if we're going to work with our north, south, east, west, he's going to travel 6 miles north. And then, zoom this in here a little bit. And then 12 miles west. So west position, something to about there. Okay. And then he gets to the restaurant. And then we're asked, how far away is Roger's restaurant from home if he were to travel in a straight line? So if we started, I'm going to use slightly different colors here for this, make it stand out. So if we have home down here, the restaurant up here, what would the distance be if he traveled in a straight line? So that dotted line that's shown up there. And now we have a visual of this thing, and we're saying this thing looks like a triangle. We're assuming that because he went directly north and then directly west, that this is a right triangle. We can also fill in some information that we've been given. We have 6 miles that he traveled north, 12 miles that he traveled west, and we are trying to find what this distance, straight line distance, is going to be here. So looking at this, we have a right triangle. We have 2 of the 3 sides. We can use the Pythagorean theorem to solve this. So start with writing out the Pythagorean theorem for yourself in its general form. Identify what the legs of the triangle are and the hypotenuse. So the 2 legs of this triangle are going to be the ones right here and right here. So we can label either of those. We can let 12 and 6 be either A or B. It does not matter which one you label them as. I'm going to let 6 be our A value, and we're going to let 12 be the B value. The hypotenuse, which is our unknown, is our X. That's going to go in for C. Now from here, we're solving this thing out accordingly. We're going to have 36 plus 144 is equal to x squared. 36 plus 144, using a calculator, and then give me 180 is equal to x squared. Now I do not want x squared. I want to get rid of that second power that's attached to it. I undo that exponent by taking the square root of both sides. The square root of 180, again, I'm doing this with a calculator because that is not a nice number. It's going to be 13 points, it's going to be gross here, 416,407, bunch of extra stuff. It's equal to x. Now we are told in this problem, round to the nearest hundredth. So I'm going to be rounding my final answer right there. So I'm going to get that x is approximately 13.42 miles. Again, when we're rounding, we always look to the digit directly to its right. Is it 5 or greater? Yes, then we round up. And we have our final answer. So again, I think these geometric problems, the geometric straight problems, they lend themselves to creating these visuals significantly more than some of the other ones do. So draw this out for yourself, or draw these out for yourself as you're going through that. So we'll take a look at the, looking at our time here, and I do want to give us some extra time for homework questions at the end. We're going to take a look at the third problem, only because that's working with a rectangle, so I want to make sure that we has some experience with setting that thing up also. So we'll jump over to our third problem, read through that, and then we'll come back here. Whoops. So we have for number 3, their examples, the perimeter of a rectangular atrium is 160 feet. The length is 16 feet more than the width. Find the length and width of the atrium. So we have a rectangle. We have been told what equation we are going to use because we're told the perimeter. So I'm going to be using my perimeter equation here and then solving for the length and the width based on the information that we've been told. So let's jump back to the blackboard. We'll make a visual for ourselves and then we'll start setting this thing up and solving it accordingly. Okay, so we have a rectangular atrium. Again, we don't need to make this thing perfect, but something like that. So we've got our rectangle. Oh, it auto-corrected for me. Thank you, program. We know the perimeter is 160 feet. Let's make a note of that off to, we'll put it right down below here. So the perimeter is equal to 160 feet. We also know the general equation for the perimeter of a rectangle. 2 times the length plus 2 times the width. And we're going to be filling in some information as we go through this, but we have our visual, let's label our visual. So the problem states the perimeter of a rectangular atrium is 160 feet. The length is 16 feet more than the width. Find the length and width of the atrium. So we have our length and we have our width. Now we have been told, again, the second sentence, the length is 16 feet more than the width. So going back to our 3.1 material, working with buzzwords, 16 feet more than the width. So that means we're going to be adding to that. So our length is, it's our equal sign, 16 feet more than the width, which is the width plus 16. So now I can go through and using the general equation for the perimeter that we have down below here, I can plug in what I know, all in terms of a single variable and numbers that we have been given. We have been told the perimeter is 160 feet. So I'm going to replace that P with the 160. We know the length is equivalent to the width plus 16. So I'm going to substitute in that W plus 16 for the width, or for the length, I should say. And then plus the standard width at the very end. So the length that we have up here is substituting in for the length here and gets written out in that form. So from this point, now we're going to go through and solve this equation for W. So we've got that there. Again, just simplifying the right-hand side down a bit further. 4W plus 32. I'm subtracting 32 from both sides because I just want the variable term all by itself. So 160 minus 32. So it's going to be 128 equals 4W. I don't want 4W, I just want regular W, so I divide both sides by 4. Better 4, there we go. Cancels on the right-hand side. And on the left side, 128 divided by 4. Use your calculator if you need to. 128 divided by 4. There we go. We're getting 32 on that side. And it's just a matter of form that I like doing. I like putting the variable on the left-hand side for my final answer. So I've found that the width is 32, but now I need to find the length, because we were asked to find the width and length of this thing. So if the width is 32, we can write off to the side for ourselves here. We had an equation that told us the length based on the width. We have it written down right up, come on. Have it written down right up here for ourselves. So our length is equal to the width plus 16. We just determined that the width is 32. So 32 plus 16 should be 48. Yep. And so we have our final answer there. So the length and width of this rectangle, the length is 48 and the width is 32. And then we are done. So I think especially again with 3.4, because it's working with geometric shapes, I would highly recommend, again, making these visuals for yourselves. You guys saw what the original rectangle that I drew looked like before the computer fixed it for me. But you don't need to be an artist. I think having that visualization is very, very helpful, especially with the geometry problems. Some of these other ones that show up like this as well. But otherwise, there's not really a whole lot else that goes along with the 3.4 material. Again, I'm going to jump us back over to our notes with this. But again, I would highly recommend, if you guys do not have these equations written down for yourself, or you want a cheat sheet for this, I would highly recommend, again, go to our Canvas site. Under the Files section, Useful Math Files, look for the Geometry Properties or Geometry Info, it's one of those two titles, and download this PDF for yourself. It's very, very handy in having all of the stuff right here readily available to you. You can print this out, you can write on it, highlight it, whatever you need to, it's your call. But I'd highly recommend getting this if you do not have a fair amount of these memorized for yourself, you don't know them by heart. But that is everything for our 3.4 material for today. I will I'll end the recording and I'll take any questions that you guys have from there.